Hey there. Today I'm going to show and think about how we can create a container image for a Python application that is optimized for size. So let's create a basic like Python fast API app. So this is an empty directory, and I'm just going to create a main.py file. And I'll just do like a hello world fast API app. So from fast API, we'll import the fast API class, create an app, create a root URL path, a root function, and we'll return hello world. Okay, so we've got our fast API server, and now we're not going to be able to run this unless we have installed fast API and any other dependencies we need. Now I know that we need two dependencies in order for this to work. So I'm going to create a requirements.txt file, and we'll put fast API and then unicorn as well. So now we have this app and it should work assuming we have a unicorn and fast API installed. But let's containerize it real quick by creating a Docker file. So I'll make a Docker file, and in this first attempt, this is pretty naive, but what you probably see quite a bit in the wild. So we start with our base image, right? So let's do Python 3, and then let's create a working directory at /app, and then let's copy our requirements.txt to /app, and then let's pip install it. And then once we have our dependencies, we'll copy over our source code. So in this case, it's just main.py. And then let's give the container a command to start. So I'll just tab complete this. We're going to invoke unicorn to run our we'll open up the main module, so main.py, and then we'll look for the app, which is referring to this, and then we'll listen on all the interfaces on port 8000. Great, so this looks like a working Docker file. Let's go ahead and do a Docker build, and we'll tag it as fast API demo. Let's call it v1. And we'll put the context as the current directory. We'll build that. This was really fast on my machine because I've already have the base image cached, and we're not doing too much except installing the dependencies, which I also had cached, as you can see here. So if you're following along, it might take a couple minutes for that to finish, but once we have that up, we can do a Docker run on our image, which I called fast API -demo, and then we also want to publish our port 8000, so I'll just do publish 8000 on the host and 8000 in the container. Boom, we run that. Oops, what did I call it? Fast API demo tagged v1. Okay, so let me add the :v1. Alright, so unicorn is starting the server process, and it's running on port 8000. So if we go here and we curl, we get our hello world response. Great, so there's our Python API. Fast API application is working, but here's the problem. If we look at our Docker images, here's our image right here, and it's coming in at a whopping 1.51 gigabytes. This is really big for a very simple fast API application. Why is it so big? Well, the base image, it really is the main problem. Let's just do a Docker run on Python 3, and we'll go to bash. So right away, bash is a piece of software that is megabytes in size, which our application doesn't actually need when we run it. It's good for doing stuff like this, like execing in and troubleshooting and whatnot. But if we look at the file system here, like if we go to maybe user bin, we're going to have all these binaries, and most of these are not really that big. Like if we go up and we do a disk usage on bin, well, actually, 114 megabytes of binaries, like, grep. Our app probably doesn't need grep. All these like Linux, GNU packages that we don't really need. That's one source of the bloat. And you can poke around at the rest of the file system, like maybe bin, where we do like du-sh on bin. Oh, that's not much there, but Etsy is small. We can poke around and eventually we'll see a whole bunch of stuff. And actually it's probably in user lib Python. Okay, 27 megabytes. Actually, so I'm just going to look up a command on how to show like the biggest files in a file system. So if we go to the root and we run this, it's going to take a minute, but here we go. This is a good view. So the user directory is over a gig. User lib is at 560. So we can see like a lot of this stuff our application doesn't need. So why are we including it in the image? It's bad for size, it's bad for download speed, it's down for upload speed, it's bad for startup time, and it's bad for security reasons too, because there's a much greater attack surface with a bigger file system. So there's something we can do that's really simple and free that will make our image so much better. So I'm going to go ahead and just like delete this Docker file. Or maybe I'll just move it. So I'll move the Docker file to like bad Docker file. And then what I will do now is just simply run docker init. If you're not familiar with this command, it's relatively new, but it's interactive. So you can choose like from some popular type of projects and frameworks. Here they have Python, so let's select that. We can specify our version. This one's fine with me. Port, sure. And then basically our command to run the container. So we'll just use that. It's already what we were using here. So this does some code generation and it creates 4 files. So docker ignore, dockerfile, compose.yaml, and readme. So if we look at the readme, this is just like some really good information on how to build your image, to run your image. If you want to use Docker Compose, they give you the compose.yaml as well with some comments that can help you get started, as well as the docker ignore. This works kind of like a git ignore file, where basically you just list out any files or patterns of files or directories that you don't need in your end application image. So like things like the Docker file, which your application doesn't depend on, most likely. README, maybe if you have like logs on your local machine, all that stuff on your local machine that you don't want included in the Docker build context, we put it in here. And the good folks at Docker gave us a really good starting point for common files that we would not want to include. And then finally the Docker file itself. So this is way more robust than the one we wrote, and I'll just go through it quickly. So we're using this new version 1 of the Docker file syntax which enables some of the more modern features of Docker build kit, which is what the Docker engine uses to build images. So a couple things here is just defining the Python version. That's why they asked us which version we wanted in the interactive prompt for Docker init. We're setting ourselves up for multi-stage builds. So we're calling this stage the base stage. And in the base stage, just setting this environment variable, which is kind of optimizing for size as well, not writing these kind of temporary, not useful PYC files, as well as some other stuff that's like kind of known issues or known best practices for Python apps. We're setting our worker to app, and then this is a good security feature here. We're creating a non-root user, because when we use the Python 3 image, we are running as root, which is a potential security vulnerability when our application is running. So typically you'd want to create a non-root user and then switch to that user when it's time to run your app. So we're getting ready for that. We're creating this app user, non-root user. Now this is something interesting here. We're doing a pip install of our dependencies, but we're also doing some cache mounts. So what this does right here is that when you do a pip install, at least in this Python 3 image, there's going to be some cache data that pip will put at /root/.cache/pip. And this helps kind of speed up the dependency installation with pip, but it does create extra files on the file system, which can lead to bigger images. So instead of putting the cache data onto the file system, we're actually putting it on the host machine's file system, which is my laptop or wherever the Docker build command is running. So when pip wants to look in its cache, it's going to look on this mounted cache from the host instead of writing those files into that image layer. So what this will do is reduce the image size and then also speed up the build, subsequent builds when you run it again. And then so yeah, that's kind of an optimization. And this is not going to work unless you have this particular syntax comment, I believe. So again, like I would say most people, and maybe I'm just speaking for myself, but when I'm writing a Docker file, I'm not really used to like that muscle of knowing to do mount caches or cache mounts is not really strong within me. So that's why like Docker init, you can kind of say, okay, I'm going to get like best practices. I'm going to get some really nice optimizations here. So that's what that is. And then here we are switching to that non-root user. Then we're going to copy all the source code in, and then we're just going to run our app. So this time, now that we have this new Docker file, let's go ahead and build it again. And we'll call it fast API demo. And this time, let's tag it as init, and we'll build that. So most of that was cached on my machine. But if we do a Docker images and we look for fast API demo, we're going to see two images now. Here's our first one at 1.5 gigabytes, and now we have 227 megabytes. So a really, really, really good decrease in size, as well as improvement for security concerns as well. So the main reason why it's much smaller in size though is like the base image. So just simply adding -slim could save you literally over like 1.25 gigabytes of space. And then we're getting a little bit more optimization with our cache mount for the pip cache, and better security by having a non-root user. So that's pretty much all I wanted to show, is really this Docker init command. And if you're, as you saw earlier, there's a lot of different languages that they support. So yeah, I just learned about that recently and thought it was cool. If you like have any other tips for me, or if I said something wrong, please let me know in the comments. And if you want to see anything in particular, let me know as well. But that's all for now. Thanks for watching.